Hi everyone, this is Andrew, and today I'll be sharing the EMC project with everyone, complete with a demo of what our team has built to date. And to start things off is just a quick introduction of our team. We have Alex and Zed, co-founders of EMC. Alex is responsible for the more business side of things, while Zed leads product development and engineering. We also have Sean as our CTO, Flash as our product manager, and Eric as our blockchain architect who is based out of Canada. As you can see here on the screen is an overview of EMC as a whole. We begin in the lower left corner with the EMC protocol and network layer, which consists of GPU-based computing nodes. Unlike ICP nodes, EMC nodes support heterogeneous hardware configurations, which means that when you see a node on the network, it could be anything from a gaming PC with a consumer-grade GPU to an IDC-hosted server with hyperscale GPU nodes to even refurbished GPU mining machines. EMC is an aggregated GPU computing network, sort of like the Airbnb of GPUs, and is a separate network from ICP as previously mentioned. EMC's control layer is built on IC canisters, where canister contracts control node registration, validation, tokenomics, and reward management. Moving on from the architectural layer, we go to the lower right corner with EMC Hub, which is an AI-oriented platform consisting of a community and forum, AI model marketplace, computing power marketplace, and NFT marketplace, all powered by the EMC network's GPU pools. EMC Hub supports serverless deployment of AI model inference cases, as well as providing SDKs for manual AI model deployment. And ultimately, what all of this is building towards is an EMC ecosystem that consists of end users, AI developers, node providers, and token holders and investors of EMC, and uses the EMC token as a utility token supporting various usage models and monetization cases, as you can see in the big circle there on the very top. And now we're just going to go take a look at our EMC dashboard. And as you can see here on the screen is a real-time dashboard of the EMC blockchain network. The EMC network currently has 24,000 registered nodes from over 20 countries around the world. And unlike ICP nodes, which are high-end configured servers hosted in IDCs, anyone with a PC with a GPU in it can register as a node in the EMC network to participate and contribute their own computing power to the network. You can click on each validated node for its detailed hardware configuration, IP address, etc. EMC uses our POC, or proof of computing algorithm, to validate the computing power of the nodes on the network. Validator nodes group computing nodes together, sending a seed to each group. Each group then uses the seed to complete the AI computations, returning the results, for example, AI stable diffusion generated images. And a valid computation result requires having the same answer as the absolute majority, or more than 50% of all the nodes who receive the seed and return a response. 15 seconds divided by the computation time for validated answers will yield the E value for said node, which is with E being our standardized unit for computational power, and EMC uses this value to assess the computational power of each node. With stuff like stable diffusion though, those of you who are more familiar with these models might notice that the same seed and the same model can yield different results. And to address this, we employ the average hash algorithm to obtain the average hash for the image. And a 95% or more likeliness between hashes is recognized as a valid answer for the proof of computation power. There are a total of 3,376 registered nodes in the EMC network that have successfully completed our POC validation process, which means that they will be qualified to run AI models and earn EMC rewards. The EMC network now has 3,500 E, again, our standardized unit of computational power, roughly corresponding to 1 V100, which means that our network currently corresponds with approximately 3,500 AWS P3.2 XL instances. This instance costs $2 an hour for spot pricing and $3 an hour for on-demand pricing, while the corresponding cost of 1 E EMC GPU is currently only about 10% of that, or approximately 2 to 3 cents US. And as you can see here is just a demo of EMC Hub. This is our landing page, and as you can see, we have 3 AI models currently. We have Stable Diffusion, Llama, and a music generation model that you can use to develop your content, I guess, with these models. And clicking into SD here, we can just see a list of all of the recommended models all of the models, I guess, that have been uploaded by users. This is a freely upload thing, but it's currently closed for SNS purposes, but will be opened shortly in the future once we're done with that. And as you can see, you can choose nodes. These are all validated nodes with the E power corresponding on the bottom to run your model. And again, this is run on canisters from the IC Internet Computer. So just speeding this up, the real time that it takes to generate is about 30 seconds, but again, we're just speeding this up for the sake of brevity of the video, as no one really wants to look at 30 seconds of the wheel spinning. And so we're just going to demo three different models quickly. One is Wonderland, which is a more cartoon-ish, neon-style thing for, scenery, etc. This is a hyper-realistic human kind of model. As you can see here, we're just going to change the parameters, and it gives me a new image in about 30 to 40 seconds. 20 for more powerful nodes if you use them. And here we're just going to use the last one, which is a more anime kind of styled model. Again, you can choose the node to run based on how much power you need, etc., how expensive it is, whatever. And just speeding this up, again, we have one image, change the parameters, calculate it, and then we have another image. And so all of our development is already or currently in the process of being open source, as you can see here with our GitHub page, starting with the dashboard, then on to EMC Hub, over here, that's the EMC Hub, then to our Stable Diffusion sample of how Stable Diffusion works, kind of like a sample demo thing. You can see it in there. Again, there's the README, etc. All the documentation is on our GitHub. Then to node rewards, reward management contracts, etc. And finally to our node management repository. And so anything that isn't on here is currently in the process of being ported to GitHub, or again maybe halfway through development and will be ported soonly. Yes, and that's all we have. Thank you.